Hello, everyone. Welcome back. Today, I'm going to be going over an example of an exponential decay word problem. The great thing about exponential decay word problems is that they all very much have the same format, where y is our final amount. So basically, after the time has elapsed that the decaying has occurred, how much do we have now? Unlike with the exponential growth word problems, this final amount is going to be less than the initial amount. Because essentially we had an initial amount and then it decays, it gets lower and lower over time. And then we have a final amount that is less. The initial amount is how much we had, what amount we had before the time was elapsed. Then we have R, which is our decay rate, and that's going to be as a decimal. So that's important to remember. Oftentimes we're given this rate as a percent. We want to convert that to a decimal. And then we have T, which is for time. And so just making sure the time is in the same units as the decay rate's time aspect is as well is important, right? So for example, if a car loses 11% of its value every year, then the time needs to be in years, right? Or let's say that the half-life time happens every couple of hours or something like that. We have to account for that when it comes to the time that we're putting in. So here's the example question. It says that Daxton buys a car for $30,000. Every year, the car loses 11% of its value. So that means the first year it loses the most. It loses 11% of $30,000. Then the second year, it loses 11% of whatever the new amount is. And then the next year, it loses 11% of that second new amount, and so on, is basically what's happening here. So every year it's losing something, but it's losing less than it lost previous years. So first it says to write a function to represent this scenario. Okay, so in this case, how can we do that? Well, do we know the final amount? No, we don't, right? We just know that there's a car. We know the initial amount was $30,000. We know the rate, right? We know that the rate is 11%. However, they did not tell us how much time has elapsed at this point, nor did they tell us what the final amount of the car is worth after that time. And keep in mind that the final amount is determined by how much time there is, right? If it's only been 6 months, then this car won't have lost that much yet, right? Whereas if it's been 10 years of Daxton owning this car, then it will have decayed quite a lot, right? The more time that has been elapsed, the lower the final amount is going to end up being, right? And so that's something to keep in mind too, is that the final amount depends on how much time has elapsed. So I'm going to say y of t is equal to $30,000, because that's our initial amount that the car was worth. And then we have 1 minus r. So that's going to be 1 minus 11% is 0.11, right? And so that's going to be 1 minus 0.11 is going to be 0.89, right? And that makes sense to us as well, in the sense that if a car loses 11% of its value, that means it's still worth the other 89% of the value that it had the previous year. And that's the power of t, where t is the time in years. And so this is the general equation we can use to represent this scenario, right? Of course, in order to actually know what the answer is, we need to either know the time, and if we know the time, we're able to find out what the final amount is after that amount of time has elapsed, or if we know how much the car is worth, we can use that in order to figure out what the time was. So the next question asks, how much is the car worth after 5 years? So for this one, what we can do is plug in 5 for t, because we now know 5 years has elapsed. It's going to be 30,000 times 0.89 to the power of 5. Then I want you to grab your calculator and type in 0.89 to the power of 5, hit enter, and then multiply by 30,000. And I'm going to get $16,752 and 18 cents. If we just round to the nearest cent there, that's about how much the car is worth after 5 years. And as you've noticed, because the car value is decaying, because it's decreasing, the car in 5 years is worth a lot less than the car was worth before the time was elapsed. And that's how exponential decay works, is that the final is always going to be less than the initial. The next one says, when will the car be worth $10,000? So in this case, they didn't tell us the time, but they told us that y of t is going to be $10,000. So there we go. $10,000 is equal to $30,000 times 0.89 to the power of t. Then I'm going to divide both sides by 30,000 to get that 0.89 to the power of t is equal to a third. And then in order to find what t is, what we would do really is use logarithms here. However, in Algebra 1, logarithms isn't part of the curriculum. So we can do a guess, a guess and check method with our calculator. We can try 0.89 to the power of a few different things and see what the answer is. One hint I will give is that it's got to be more than 5, right? It's got to be more than 5 years, that's for sure, because we know that after 5 years, it's still worth 16,000 something. And so for it to be worth 10,000, even more time must have elapsed at this point. So that's a good place to start. If you do know how to use logarithms, feel free to do that. But you can also do an estimation here as well. And as it turns out, if we do an estimation here, we're going to get about somewhere between 9 and 10. I would say slightly closer to 10 years, but not quite, right? About 9.7 or so, right? 0.8 to the power of 9.7 years is not quite on the money, but very, very, very close. So we can go with that, or maybe 9.8 would be even closer. 0.89 to the power of 9.8, or no, 9.6. Yeah, it's going to be even closer. So t is about 9.6, or you could even say the car will be worth $10,000 partway through the 9th year is also fine as well. And so there we go.